Alright, we want to graph the solution to the system of linear inequalities. 2x plus 9y is less than 36, and 2x minus y is less than 18, or less than 16. But I just realized that on the answer key, or on the question, this is actually a greater than 36, so let me make that change. So 2x plus 9y is greater than 36, and 2x minus y is less than or equal to 16. What I want to do is just graph each line independently and then look at what area is double shaded. So I'm going to start with the 2x plus 9y equals 36. If we plug in a 0 for x, I'll just have 9y equals 36, so y would equal 4. And if I plug in a 0 for y, I'll get that x should be 18. So I need to draw a line that connects 0, 4 and 18, 0. And let's go ahead and find the intercepts down here just so I know what I'm looking at. If x is 0 in the second equation, I'll get y is equal to negative 16. And if y is 0 in the second equation, x would be 16 divided by 2, it would be 8. So I need to go out to 18 on the x-axis and from positive 4 to negative 4. So let's count by 4s maybe. So there's 4, 8, 12, minus 4, minus 8, minus 12, minus 16, and yeah, keep going by 4s. 4, 8, 12, 16, 20. So our first line goes from 0, 4 to 18, 0. 18 will be halfway there between 16 and 20. And this is a strictly greater than, so I want to draw that in with a dashed line. I want to draw in a dashed line there. And our second line goes from 0, negative 16, 16 on the y-axis, negative 16 on the y-axis, to 8, 0. 0, 8 on the x-axis, or 8, 0 on the x-axis, and that's a equals 2 on that line, so I can fill it in solid. And I do want to find this point where the two lines intersect. That's a really nice point to know where that is. If I just take that equation, if I look at that 2x minus 9y equals 36, and 2x minus y equals 16. Oops, that should be a plus 9y. If I take those two equations and if I multiply the bottom one by negative 1, I can add the two together and I'll get 10y. The two x's will cancel out. I'll get 10y equals 20. So it looks like y equals 2. So the y coordinate over here should be 2. And if y is equal to 2, let's go into that with the bottom equation. 2x minus 2 equals 16. So 2x equals 18, adding 2 to both sides, and x would be 9. So this is the point 9, 2 is that intersection point. Alright, and then I got to do some shading. Some shading to do with on this top equation. If I look at the 2x plus 9y is greater than 36, if I try 0, 0 in there, I'll get 0 is greater than 36. That is false, so I don't want the 0, 0 side of the top equation. So I want the side that's above that dashed line. And for the bottom one, if I try 0, 0, 0 for x and 0 for y, I get a true statement. I'll get 0 is less than 16. If you work all out the math there on the left side, you get 0 is less than 16. That's true. So 0, 0 is a solution. So I want the 0, 0 side of that one. And so the place that's double marked, that's marked twice in our solution region, would be this area that's on the top part of the intersecting graph that we're shading in here. That would be our solution region. And there's our solution. The solution to that system of linear equations is anything that's in the shaded region up there.